The Tennessee Math and Science Standards have recently been revised, and now within the science there are embedded strands for engineering and for mathematics. And it's not always obvious to science teachers how to integrate those kinds of ideas into their courses. Likewise, with the new math standards, there's a focus on math processes, on conjecture and experimentation and data analysis and reasoning and those ideas. And so this context gives all of the teachers involved a way to think about their new standards and how to integrate those ideas and move away from, well, this is math class. Well, maybe this is a class where we can talk about math and engineering and science and all of those kinds of things at once. So hopefully that's something we're fostering as well.
Still, I mean, one of the main themes is having the teachers as the principal investigators. So they really get to experience the full essence of research. I mean, they are not just put into an experience where they follow, they're not lab tech, as Lynn, the server here was actually saying. They know the full process. And if somebody understands the full process, the full excitement of it, they're able to go back and implement, that. So we're requiring, the participants here, as they are doing their part of the research, to actually develop what we call as the legacy cycle, which is really a learning module that's based on hands-on, real-world activity, to get the students, to understand what they have been doing in a realistic way, an exciting way, not just the mundane, exercise that doesn't have a real application behind it.
These kids most of them are not yet sold on the fact that they're going to college. A lot of them think, they're still being forced to go to school. You're making them do this work. It's like torture almost. So, you have to make those things interesting and fun to them to make them want to do it. And, science is the easiest way to do that. Any kind of hands-on activity that they find fun, and then if they know that they can have a career doing something like that that's actually fun, then they will start considering maybe going to college and entering into those jobs.
Another reason that I really think I'm here is just for the experience, so I can take engineering back to my classroom, so I can take the things that we learn here and impact my students and try to get them excited about science, technology, engineering, mathematics, and the futures that they could have in those fields, because so many times our kids don't go into those fields because they're scared of them. And so I think the experience that I have here and what I learn here, I can take back and really pump those kids up about their futures.
Because we are not given any money to buy materials and extra things for our students, especially in science, because if you do a lot of hands-on activities, you pay for it out of your own pocket. If you want to do something extra exciting, fun, or new, you buy it yourself. So this provides a way to use new technology, find new resources, and not have to spend your own money.
Where you're really integrating all aspects of engineering into this. I mean, the big project that I've been running in manufacturing in metal casting, and we had faculty from probably every department in the College of Engineering who participate, in it. But you can see here, manufacturing, we are really linking between the low-tech up to the high-tech. Ms. Thurber here, and who else is working? Ms. Thurber is working on manufacturing of concrete, which is one of the maybe most traditional manufacturing, things that are in the U.S. or maybe all over the world. But at the same time, she and with her mentors found, the cutting edge of what needs to be understood in such a traditional, manufacturing. But at the same time, we're working with nanotechnology, which is at the cutting edge. We're working with, fuel cells. So some things that really are not just, buzzwords. The teachers get to understand why are they important to our future as a nation. So right here, we're covering the full spectrum from the traditional, finding the exciting, elements of technology that can be inserted into these, into these manufacturing methods. And going all the way to the high-tech, the cutting edge, and seeing how this also can be applied, where the research fits in both traditional and cutting edge, research.
Interesting, because I didn't know what to expect coming into it. And when I realized it was a 6-week program on a research topic, I thought we'd just get to play in the lab for 6 weeks. But especially this first week, this program really does a good job of synthesizing what it would be like to be a researcher in the profession of researching. The proposals that you have to prepare, the pressures and the responsibilities to answer for what you're doing to not only the authority figures, but even to your peers, and let them accept what you're researching, and that adds value to the project, I think.
The first week, stress level shot through the roof. But I did realize in the end that if I had not been pushed to accomplish those tasks in that time period, I would have procrastinated. I would have dwelled on what is my question, what am I going to do? I don't know. But since I knew that I had 3 days to do it, I pushed through and I got it done. So setting those standards high is okay, because that pushes us to do our best and to get it done.
I truly expected to be babied and led along more than what reality turned out to be. I did not expect so much pressure to come up with my research question, to come up with my plan, to come up with all of these things that I felt incapable of coming up with. And I had some tearful moments and a lot of very high stress levels while I was trying to figure out whether or not I could do it. But after the end of the first week, I believe that I can do it, and it's because of that pressure to those high expectations. You're not going to meet a high expectation if it's not there for you to meet. The reason I'm in this program is because I feel like I will be a better teacher of engineering if I have an understanding of what goes into the engineering. How can I teach a student how to design and implement an engineering process when I've never done it, when I've never studied it? And that's what I'm hoping to get out of this program, is an actual feel for what goes on in engineering, so that I can bring that back and bring back that excitement to my students.
I would have to say that it was probably the best project group that I've ever been in, and I've been in a lot of different types of groups, but the things that I had learned, being able to go in depth, real research into a problem, being able to bring that back in the classroom has been just a tremendous difference in when I stand up in front of the class and start talking about the research. I can talk about my research. This is specifically what I've done. I actually have my little Gordonsville Tiger casted piece sitting on my desks, and so it sits there all the time, and so they look at it and they ask questions about it. But those are things that I can say, well, when I was doing the research, I ran into this problem, and you're having a problem in the lab, and so you've got to figure these things out. And so that part of the teaching, it goes beyond even your legacy cycle, which is a great system of bringing those in, but even beyond that, it'll bring into all of your teaching, even if you're not doing the legacy cycle. What actually you've experienced enough that you can talk with passion about, what actually is going on in the research field. And they don't understand that. And I didn't understand that until I did it.